We have the talk on outsourcing of space projects, learnings from other countries. We have with us this afternoon Rina Raman, Vice President and General Manager, Embedded Acceleration Division, Data-Centric Group, Intel Corp. Ladies and gentlemen, please extend a warm welcome to Rina Raman.
Good afternoon. I want to thank, first of all, IESA for the opportunity to come talk to you. I appreciate that I've been given this opportunity. I'm actually very excited to be here, to be able to discuss this with you. It's an honor and a privilege, and thank you for listening to me as well. I'm excited because India has actually come a long way in space. I'm very excited to see how much India has invested in space. Personally, for me, I was born in India, but my family, my parents moved away to the US when I was 11. So I'm Indian by birth, and India's my birth country, but America's my adopted country. And so it's an exciting time for me to come see what happens here in India. And the other thing that I also always find is that, you know, when you look at space, what people really find, I think, exciting about space is the unknown, the frontier, something unexplored. It really provokes all of our imagination. But in addition to that, it also gives us a perspective of ourselves, because when you're out there in space, you get to view us from out there, and you get a view of us from a different perspective. And I feel that's what I'm getting being here amongst all of you, is a different perspective of India from afar as well. It's been exciting watching the progress India made in space and the Chandrayaan 2 project. I think everybody was watching it, you know, with avid, you know, bated breath up until the last minute. And even though it didn't go completely 100% as planned, it was still a huge accomplishment for India. India is one of only a handful of countries to even get into the orbit and get to the moon. And the other part that I found absolutely very touching was the response of the nation to what wasn't a perfect mission, in the sense that when at that last moment, in that last 100 meters, things didn't quite go the way it wanted. Obviously, everybody saw on national television the disappointment that the leaders of ISRO, like Dr. Sivan, felt. And it was even more touching to me, like the next day when I saw the cartoon in the paper and in the news of a outstretched Mother India embracing Dr. Sivan, and it speaks to the nation's strength, the nation's character, that you embrace, and I think really spoke, characterized how the whole nation felt, and how you embraced somebody who was a leader and who had actually made a huge amount of progress, and even though it wasn't perfect. So kudos to India, and for having that strength of character. So I have to, of course, start out on being part of a large Intel organization with a legal notice, and I'm sure you'll all very quickly read that and know your rights as well. So having witnessed what the world has accomplished in terms of the space industry, I'm really glad India is investing in space and appreciating the challenge and taking on the challenge. So coming from the US, on US soil, I can tell you about what's been happening. So NASA's planning to send astronauts back to the moon, and the plan is for this to happen in 2024, 4 years ahead of what their original plan was for the Artemis project. And since the first time that somebody went to the moon about 50 years ago, actually almost exactly 50 years ago in 1969, humans haven't really been back since 1972 to the moon. And there's been, in the last 47 years since somebody's been to the moon, there has been a huge amount of progress in terms of technology. when I look back 50 years ago at that first moon landing, the Apollo's guidance system computer ran at only 1 megahertz. Could you imagine? The guidance system ran at 1 megahertz. And the Intel 8086 processor wasn't even around. In fact, it wasn't around for almost 10 years after the first moon landing. It was almost 1979 before the Intel 8086 was around. And in fact, these 8086 processors were actually used for a host of diagnostic and equipment in the first space shuttle in 1981, and was also used for about the next 20 years until the components became, were hard to replace. The replacement parts were hard to find. And what really this points out to is they were really pioneers, and what they had to work with back then versus what we have to work with now is amazing. And space is harsh. It's harsh for microelectronics, and it's harsh for humans. And in order to be able to ensure the successful missions, NASA and other government entities have actually started studies and looking at the effects and the experiments to mimic the conditions and environments in space to prepare our astronauts for the venture. And Intel has been partnering and involved in some of the research and helping influence the technology evolution for the future missions. And we would love to be able to partner with you as well. One of the areas that Intel is involved in is NASA's Frontier Development Lab. And this is a public-private partnership between NASA and IESA in Europe, the SETI Institute, the institute that studies for terrestrial life, and the commercial space, like SpaceX and Blue Origin, and also AI computing. Or AI companies, I should say. And this is so that we can prepare for the next lunar landing and next lunar mission so that we can help with decision planning and when we send astronauts back into the moon. FDL in particular has been chartered with solving some of the most complex space mission problems with the latest AI technology. Items like lunar resources, lunar mapping, Earth observation, as well as space weather. And the format of this lab is generally an 8-week accelerator, and with experts, like normally 2 AI experts and 2 planetary science experts in key challenge areas. Intel has supported 3 of these teams in the 2017-2018 timeframe for a total of about $285,000 of sponsorship. And then in addition to that, we have in 2019, Intel and Google have each contributed about $500K to cover 8 different challenges for NASA FDL. This includes the US FDL as well as the ESA FDL in UK. And then there's normally about 2 designated mentors who will bring Intel subject matter experts to advise the experts, advise the teams as the team progresses. And some of the results of this research may also be applicable on Earth. So for example, there's a disaster prevention challenge that happened in 2019. And the team looked at flood detection and flood augmenting flood action. So what do you do once you detect? How can you quickly and possibly give satellites more autonomy? And then there was also a research on the interaction of the northern lights, which is normally a phenomena near the north, like we see it in Alaska or some of the Scandinavian countries, with GPS outage. And so they looked at the correlation between those. And the results of that are actually being published at the end of this month on September 30th, and it'll be an open source document for anybody who wants and is interested in reading about it. And the other area where Intel has been involved is with DARPA. We've supported the DARPA Subterranean challenge to autonomously map the tunnel systems underground. So we sponsored NASA Jet Propulsion Lab entry with real sense cameras for their advanced wheel rovers, which is called a Husky, and drone and rover hybrids, which are called rolocopters, and JPL partners with Caltech, MIT, KIST, which is in South Korea, to build these robots. And then the team actually won second place this year in the first competition that happened in August of this year. So the idea of this challenge is for smarter mission planning, applicable for space exploration, as well as for first responders. You know, I think back, personally, this sort of excites me, not just because it's space, and everybody finds space exciting and what we could do there and what we could find there, but also the applications here on Earth. I think back to about a year ago. I'm sure most of you remember, because I know everybody in the US and everybody that I spoke to in different parts of the world as I traveled around were glued to the TV, watching with complete concern as there were 12 young boys that were part of a football team in Thailand and their coach that were trapped in a maze of underground caves, which was filling up with water. I don't know if most of you remember that, but you know, it was very heart-wrenching. People weren't sure if they were going to make it. The boys were scared. The messages that they got back, you could see how scared that they were. You could see how scared the parents were. You weren't sure if they were the children were going to live. And it really, I think, touched the heart of everybody in every part of the world. And the way they actually went about the rescue process was they had to first send in divers, like experienced divers, you know, that were capable of doing scuba diving, not just scuba diving in the open ocean, but scuba diving in an underground cave where you don't know the path, it's really claustrophobic, you might not have enough light. And they had to first map out the whole terrain. And they could only map it out sections at a time because they would run out of oxygen in their tanks, so they would go as far as they could, map it out, and then they would come back. And then another team would go. And they first had to map out the whole thing. And in the whole process, they also had to take food over and supplies over to the kids so that they could keep going while they were figuring this out and figure out the best way to bring these kids out. And these kids weren't expert scuba divers, so they had to prepare them, practice with them, and then bring them out. Now, and you know, the Thai Navy SEAL, a hero, Samam Kunun, actually lost his life in the process of saving these kids. Now imagine if you could have this done autonomously, and if you could have a mission where you could use robots in the rescue, where they could actually go out and map the whole thing out, what it would do for you, right? So that's one of the reasons I find this challenge super exciting, is it's not just what it can do for you in space, but what it can do for us as humans here on Earth. And then as Intel, we get more involved in these kinds of research. We're being asked for more help to bring Accelerator to space. And we are happy to assist in whatever way we can. And we want to partner, as I said, not just with our partners in the US in terms of NASA or in Europe with IESA, but we would also like to partner with ISRO here in India. So now that I've gotten you excited about Intel's involvement in space research, I wanted to kind of go over a little bit about Intel. For those of you who are not familiar, it is probably the largest semiconductor company that's been around for a long time. It was actually originally started in 1968, so over 50 years ago, and it was founded by Robert Noyes and Gordon Moore. And Noyes and Moore left Fairchild Semiconductor, where they were working to incorporate a new venture, and which they started out calling it NM Electronics, but then changed the name to Intel over the course of the year. In terms of size of the company in dollars, it is last year at 2018, the revenue was $71.5 billion in revenue, which was a record high for us, and the revenues contributed from key business units that are shown below. So you can see actually the different products at the very bottom that Intel makes, and all of these products contributed towards the $71.5 billion in revenue from Intel. In terms of size of employees, there's 107,100 employees as of the end of 2018, and approximately 50% of these employees are located in the US, so which means the other 50% are elsewhere in the world. And here in Bangalore alone, we have about 8,000 people at the Intel facility here in Bangalore. And approximately, when you look at the whole global workforce, about 87% of the workforce are actually technical. They're in technical roles. So very much a technical company, very focused on engineering, and huge commitment to R&D. So when I look at Intel's commitment to R&D to maintain our leadership position in semiconductor manufacturing, and our prevalence in data center technology, as well as our investment in AI, we invest $13 billion each year in R&D alone. So $13 billion in 2018, right? And so it's among the top 5 companies in terms of spending for R&D. And there's about, if I look at, we obviously make semiconductor chips, and if I look at the semiconductor chips, our largest gate count, or transistor count in our latest generation product had over 200 million had over 200 million transistors in one chip. Okay, so I hope that gives you a little bit of a breadth of what we are about. And as you can see, we have products in the client, so which is like your laptops and your PCs and such, which is where we originally started, to data centers, which is where our company's transforming and evolving into. We're looking at new technologies. You might have seen some of the Intel drone shows. If you haven't, you can YouTube it. Go look at the Intel drone shows that we put together with Intel drones and Intel drone technology. Memory solutions with our Optane memory, artificial intelligence solutions, programmable solutions with FPGAs, as well as our Internet of Things IoT solutions as well. So the other thing that I would point out about Intel is most people think of it as a semiconductor company, and that's our roots. That's where we started. But out of the 107,000 plus employees that we have, over 20,000 of them are in software. So almost a fifth of our company, almost 20% of the company writes software. And so, which is what I think is a little bit unknown to most people and always a very interesting thing to look at. And we actually work on software on many different levels. We have OpenSwitch, FlexRAN solutions, OpenVINO. OpenVINO is a platform that allows us to actually write code that could target a processor, or it could target an FPGA, or it could target our Movidius vision and video solutions. Now that I've kind of given you a little bit of breadth of what we do, I want to talk a little bit about the division that I belong to. The division that I'm part of is called the Network and Custom Logic Group. So we do ASICs, structured ASICs, like from the company IESA that Intel acquired last year, as well as FPGAs. And the main areas that we focus on could span anywhere from the edge, all the way from the smart device edge, all the way through wireless networking, multi-access edge computing, core network, all the way to the cloud. And part of what is really interesting about this is if you look at the breadth of Intel's products, they generally fall into one of 3 categories, or actually in multiple of these 3 categories, but these are the 3 that we focus on, which is move, right? Moving data, so the networking part, you're moving data either through Ethernet or silicon photonics products, et cetera. Store, which is like our persistent memory Optane DC products, or our solid state drive, and our other memory products. Or process, which has been the traditional bread and butter of Intel in terms of either processors, Xeon, Atom, core processors or FPGAs for acceleration or MOVIDIA's processors as well. And then on the right side are our software products in the form, as I mentioned, about OpenVINO and DPDK. So with the different products that we create, Intel's actually able to offer an end-to-end solution. So as an example, you could start at the endpoint there in a video processing example, and you could use a MOVIDIA's chip in your camera that can go into gateways, that can feed into a gateway. And the gateway can consist of a processor and another MOVIDIA's chip or an FPGA. And you can do most of that processing in the gateway before you send the data to the data center for storage or further processing. This is really important because first when cloud became popular, people thought they were going to send all the data up to the cloud, and the cloud was going to do all the processing and then send you back the final answer, so to speak. But I think as people have moved towards this direction, they're finding that maybe I don't want to send all the data to the cloud for multiple reasons. Number one, privacy concerns, security, but also latency. If you're sending all of your raw data up to the cloud, it's going to take a really, really long time. So maybe you want to do some pre-processing in a gateway closer to the edge and then decide what do I want to send out into the cloud. So that's part of what we're offering here. And then it doesn't just provide the chips, but the software framework as well that supports all the chips that were listed there. Okay. Now that I've talked to you a little bit about the background of Intel and the products that we offer, I'd like to talk a little bit about what are we doing to accelerate challenges with FPGAs in particular. So here we use a Xeon processor along with an ARIA or Stratix chip to be able to do workload optimization. So depending on the workload that is prevalent in a particular system, what we're finding today is systems are not homogeneous anymore. Systems are really heterogeneous because you could have different workloads that come into the system, and depending on the workload, a GPU might be a better solution, or a CPU might be a better solution, or an FPGA might be a better solution, or an ASIC might be a better solution. So if you have the option of one or more of these and being able to pick and choose and put together your system with a wide variety of choices, you're more likely to be successful in your system. And that's basically Intel's strategy and approach, is that we offer a multitude of offerings, everything from the CPU, FPGA, MOVIDIA's, processing, ASICs, as well as GPU functionality. And then in particular, these are the NCLG offerings, everything from the lowest cost and lowest power CPLDs with the Max, to Cyclone, which offers cost and power balance, and also the Cyclone offers SoCs. So there's Cyclone 5 SoC, as well as transceivers are built into these Cyclone devices. And then in the mid-range, we have ARIA, and ARIA also comes with option of FPGAs or SoCs, including transceivers. And then Stratix, which is really our higher-end devices, which are optimized for bandwidth. And then our latest 10 nanometer product that was released and shipping to customers earlier this year, Agilex, and a structured ASICs, which I mentioned before, was acquired from a company called IESA, and this allows you to have half the power at half the cost of a equivalent FPGA type design, and supports higher volumes as well. And we also offer power products in the form of Empyrean power regulators and power products. All right, and on the bottom there's a list of resources that allow you to take advantage of some of the offerings on top. So there's embedded soft core and hard processors in the form of Neos and ARM. So the embedded SoCs have ARM in them. We have design software in the form of Quartus. That's the design tools you would use to actually program the FPGAs, because I always say the FPGAs are like a whiteboard. You can write whatever you want in them, and we also give you the software along with the chips. They're like the pens that allow you to write on that whiteboard, and it's only limited by your imagination. and development kits and COTS boards, which allow you to do development on the boards. Programmable acceleration cards. These cards have both Xeon processors or other Intel architecture processors paired up with an FPGA for you to be able to accelerate your workloads. And then reference designs such as pulse Dopplers or RF front end, matrix inversions, and design separation, which you can use as a starting point to do your own designs. And we offer a rich partner ecosystem to be able to support your local needs. That the partners are present here, local, indigenous, to be able to do designs with you. And as I mentioned, Agilex is our latest and greatest product. It's on 10 nanometer. It allows you to process data with up to 40% higher performance than previous generation, up to 40% lower power. And in terms of DSP performance, which is really important in space and defense applications, it has about 40 teraflops of DSP performance. It allows you to store data. It supports DDR5 as well as HBM memory, as well as the Intel Optane DC persistent memory support. And then allows you to move data through 112 gig transceivers, which is the leading transceiver rates in the market. No other FPGAs have products at those rates. And also we have Intel Xeon processor coherent connectivity on board the FPGA, so you can connect to a processor very quickly along with PCI Express Gen 5. The other thing I want to quickly point out about the Agilex architecture is that we use the EMIB technology to marry tiles to our architecture. That you'll see the different colored tiles around the periphery. And the yellow there shows the EMIB that connects the fabric in the middle to those different tiles. This allows us to add new technologies that come in different spaces, in different markets, very quickly onto our single packaged device. All right. Also, in terms of simplifying bring up and lower cost, it allows you to do complete power management on the power rails, including our Empyrean device with the Agilex. It allows you to save space and reduce cost and achieve advanced performance. And we actually have complete, out-of-the-box solutions pre-done for you that you can actually download from the website down there, intel.com/Empyrean. So this is the complete continuum. We offer FPGAs so you can first get to market quicker than anybody else. You have flexibility while you're still figuring out your design, while the market is still being set. And then once you have your design set, you could optimize it for time to market, because it's relatively easy to move to a structured ASIC, eASIC, and at half the cost and half the power, and so maintain your performance. And then if your volume is high enough, you could move into a full-blown ASIC with the highest performance, lowest power, and cost. And we can support your design all the way through the entire product life cycle. Okay? And these are the different vertical applications that I'm responsible for in my division. I focus on these markets, and as you can see, the radar and defense and surveillance are key parts of areas that we focus on, and just in general, military, aerospace, and government. Okay? And in particular with defense applications and solutions, here are some of the areas that we're focused on: ground and naval electronics, rugged systems and devices, avionics, as well as looking at communication networks, avionics flight safety, vehicle and electronics, unmanned systems, training simulation, command and control, as well as ruggedized systems and devices. And we offer solutions in all the areas listed on top, and the ones on the bottom, we have use cases and applications, and we can work with a partner to develop solutions in that area. All right, so with that, I think the message that I really want you to leave with is, number one, Intel provides a unparalleled breadth of portfolio, everything from high performance compute and connectivity, agile and flexible AI acceleration, and anything to anything heterogeneous chiplet integration, so CPU, NVIDIA's GPU, FPGA, EASIC, and a proven Intel EASIC device customization path. And the second message I really want to leave you with is that we are very committed to helping you in your efforts, and however we can help you, please reach out to us and let us know. And then last but not least, October 8th and 9th in the US, near Washington, DC in Maryland, we have what's actually called the Federal Summit. We will have many organizations from the US government present there. And it's our 5th annual Intel Federal Summit. And you can learn from the world's foremost technology innovators about solutions in this space, and meet many of your counterparts in the US, and also benefit from our partners who are using Intel technologies to deliver breakthrough intelligence. You can also discover emerging mission-specific solutions before they come to market. So these are things that we have not announced. These are things I'm not talking about here in my quick 30 minutes, but these are things that you can find out with an NDA. And you can also find out answers to reduce your costs and more efficiently implement your solution and accelerate time to market. And if you're interested, please look at federalsummit.intel.com for more details. And thank you.
I'd like to thank Rina Raman. I'd like to request Mr. Anil Kumar, past chairman IESA, to present a small token of appreciation to Rina. I'd like to request all of you to please give her a big round of applause once again.